Good morning and welcome to the summer workshop series offered by Pentair in the Pentair Water University world. Today's topic is one of twin tank solutions. What twin tank solutions does Pentair offer in the Fleck line, and why do they make sense? Okay, why double up the amount of equipment, essentially? So the systems we have, we're going to talk about the advantages of the twin tank system, how they work, standard systems, and the 9100 twin sensor system. And it's really all about water and salt efficiency for end users. With a twin tank system, what differs from a single tank is that we no longer need a reserve capacity, or if we select one, it can be very, very minimal to compensate for fluctuations in hardness in the water supply. In a typical single tank softener, you're going to use as much as 30% reserve capacity. So we've got a 1 cubic foot tank. What we're really saying is we have a 0.7 cubic foot of actual usable resin. And that's going to impact our regeneration. It's going to be 30% more frequent than a standalone single, a single tank is going to regenerate 30% more often than a twin tank system. Why? Because the twin tank system is going to fully exhaust the resin before it switches over to a second tank that's ready to go. So that can be profound long term. Whatever the reserve capacity of a single tank is, you're going to get that increase in efficiency of both water and salt by switching. So no capacity waste. And the other thing is if you're dealing with a business that requires soft water 100% of the time, this is a great choice, because as soon as you switch, you get soft water. There is also the added benefit of treated water regeneration and brine refill. You are not going to be regenerating the spent tank with hard water. You get no competing chemical kinetics there. You're getting straight exchange processes. And everything that's going to be in your brine tank is going to be sodium chloride, because you are filling it with soft water. So you're not going to get any competitive exchange kinetics going on. Using treated water ensures the best dilution and solubility of that salt and that brine in the tank. There is no drop of debris to clog up the brine tank and draw assembly. I have that issue in my softener at home with iron in my water. I have to clean out my brine tank at least every 6 months because I drop out so much particulate now into my brine well that it clogs injectors and screens. So soft water refill and regen solves that issue. And this makes sure the resin is fully regenerated and extended its life by reducing fouling. We're not introducing raw water to the softener except to soften it. Nothing in the regeneration process. We're managing the contaminants and the competitive chemistry that's going to take place. So this eliminates several issues with single tanks right from the start, and 24/7 soft water. Twin tank advantage, lots of common parts across our spectrum of components here. The upper seal kit is a 5600 piston and seal kit. You have a 1600 brine system, very familiar injectors used across a broad spectrum of our products. You have the SXT controller that gives you lots of versatility with a twin tank configuration. You have a full range of different meters available here, from turbine to paddle wheel, both standard and extended ranges as well. And you have all the plumbing configurations that you're going to need to adapt up and down. So you have familiar service components with this as well, so it will overlap with things you're already doing. On the twin tank systems, we have this convenient label that indicates the position the pistons are in when they are regenerating and in service. You can see tank 1 or tank 2. See, it lets you indicate which tank is in service. So you can also troubleshoot the controller to make sure the proper tank is in service and it's aligned. You can also make sure your piston and operations orders are in line by checking this decal as well. And it allows us to see what's going on as pistons are moving in real time. Now, when it comes to troubleshooting twin piston systems, you have to remember the upper piston regulates regeneration on both tanks. This is just like a 2900 with twin alternating system, but with only one valve. We're just switching the tanks, not switching back and forth between valves. You still have the lower piston acts as a standby for the other tank. Okay, so if you are having any issue that uniformly happens on both tanks, that's most likely an upper piston related issue or regeneration assembly fault. Okay, now if you're having one system that occurs, a symptom that occurs on one tank but not the other, it's most likely related to a lower piston issue or something with that individual tank, like fouling or not a proper backwash, improper fill, something like that's going on there. So always troubleshoot both tanks when you're troubleshooting one of these systems. We have the 9000, which is a twin brass, low lead brass version of this assembly. It's really twin tanks. You can use this system up to 16-inch diameter tanks. That's up to 4 cubic feet apiece. That's 8 cubic foot system and consistent soft water back and forth. You do have hot water capable units up to 180 F, 150 F for metered units. And you can have 1 inch or 3/4 inch meters on this unit. You do have available auxiliary switches and a lead-free brass body. Continuous flow rate of 21 GPM and a peak of 28, but a max backwash of 8 GPM. The 9100 is the thermoplastic version of the 9000. Exact same specs, but it eliminates any corrosion due to copper or brass issues or aggressive waters. This is for cold water only. We have about a little over 7,000 of these out with one specific global coffee chain out there. We have about 7,000 of these. The Pentair 9500. This is just the inch and a half version of the 9100 or 9000. So you have up to 24-inch tanks here. So that's up to a 20 cubic foot combined system with continuous flow of 38 GPM and a peak of 49. With a 16 gallon per minute backwash, with up to 1.5 inch commercial meters, up to 180 degrees F for hot water. If you're going metered, you do need to stick under 150, lead-free brass. And if you think about this, 10 cubic foot in each tank, you could actually manifold these into parallel flow, in which you could have 40 cubic feet of softening, 220, a 10 and a 10 right side by side with each other, giving you 20 cubic feet of resin that automatically switches when it exhausts, always producing soft water. The Pentair controllers that we have these on, we have the 3200 electromechanical series of controllers that are available on this. You have the SXT as well, and the NXT2. The XT is no longer available. We do have service replacements out there. The SXT is truly versatile in this regard because you can program upflow and downflow with second backwashes with this unit as well. You have the NXT2, which you could actually then network these together as a twin system as well. Now, the 9100 TS system is a twin tank system that now we're stepping up the game and applying some proven sensor technology to really understand what's going on in the water quality. And this can be very, very critical to certain operations, especially when doing things like kidney dialysis, pretreatment, ROs, plating process water, where you need soft treated water 100% of the time. This makes, with the twin sensor system, this makes this the most efficient water softener on the market. We use our Logix controls from the AutoTroll side of things to control the sensors. We have patented sensor technology with upflow regeneration with this unit. So we're maximizing the amount of efficiency, soft water regenerations, and brine refill while switching tanks and delivering 24/7 soft water. Can save up to 35% in regenerant and water with these units. So what's going on here? We have a patented cell technology that measures the conductivity through the resin and is able to calculate the true capacity and accommodate for fluctuations in hardness. LA is known for this with varies from 5 to 20 grains per gallon hardness. I've seen this over the last few years. When there's a drought going on in California, you can push up into the 40s in grains per gallon hard water. And when they get plenty of water, it drops into the 5 and 8 range, just as it's doing now. I know dealers that are selling RO systems and softening systems now saying, you know what, as soon as we get another drop, you're going to need this system. We've got good water now, but you won't have it forever. So what we're doing here is measuring the different conductivity in water. When the water's coming down the unit and coming back up in flow, you're going to get a regeneration front where you're producing nothing but sodium heavy concentrate water, right? So that's going to be measured going through this unit. Well, when this resin becomes exhausted, it's not exchanging resin, any sodium out. You're going to change the conductivity of the water from sodium to calcium. There's a slight difference there. This top sensor picks up that change. So the controller now starts counting gallons from here to here. And based on the tank size, we know exactly how much resin that is and how much capacity we should have left. And once that wavefront gets here again at the second probe, it knows how much resin is left in the tank and then triggers a regeneration based on that amount of water going through the tank. So what happens with this unit is if hardness goes below the set point, the system gains in water efficiency and salt use. If it goes above your hardness initial programming, It'll maintain soft water and prevent hardness, bleed through, and damage to equipment. So what this is doing is actively sensing and adjusting for water conditions in that municipality or in that well to compensate for that seasonable variation. I know of water systems in Pennsylvania that switch from well to reservoir throughout the year, and it's a change from 5 or 6 grains of hardness from the reservoir to almost 30 out of their wells. And that is done in a seasonal pattern. So you either have to go back out and readjust all your softeners twice a year, or a unit like this will pick that up and self-adjust. So what are we talking about here? So if you have a 4-person home at 20 gallons per day, grain per gallon, hardness up to 100 gallons per day per person at a 3-pound salt setting, this is the amount of capacity to treat that. The salt you're going to use per year doing so, if that all remains the same. Well, if it slips up to 25 grains per gallon hard, you've increased the amount of capacity you needed to treat that water by 25%. If you didn't adjust up, that means that 25% of the water that's going to make it through a cycle is going to be untreated compared to 20 grains per gallon. And you would truly need 730 pounds of salt to treat that water. So you're not treating 20% of that water, and also you're not selling salt to that customer as well. Water is untreated 150 gallons prior to each regeneration in this scenario, just from a 5 grain per gallon switch. Now, if it drops down below to 15 grains per gallon, I only need 219,000 or 2,190,000 grains capacity to be treated here. I've now wasted 25% of my capacity because I couldn't adjust down. You only needed 438 pounds of salt to treat that hardness of water. That's 147 pounds of salt that is overused. So this unit dials in that variation. With the 9100 TS, you don't lose any capacity or overuse salt. The twin sensor is actually capable of greater than 5,100 grains per pound efficiency, real world applications. So if you're running into brine restrictions, this is a good selection to choose in those environments. You're going to be using the entire capacity in the tank, soft water refill, and you're going to get exceptional efficiencies out. No need for a 30% reserve. You improve efficiency in water conservation further, and 5% of the change of improvement in a water per grain in improvement of water efficiency. Better protection for commercial equipment when hardness is variable. Compensates for resin bed aging. So as it's breaking down and deteriorating or getting backwashed out, you're able to maintain those higher levels of efficiency because you're actually measuring what's going on in the water and the resin, not just guessing at it. Makes more efficient use of high capacity or specialty resins. So if you're dealing with some of those specialty iron removal resins or things like that, you'll be able to sense those and adjust your programming for softening applications. Why? It's actually sensing what's going on in the water. You're able to extract everything you can out of it. And that's really, really a big issue. I did a comparison study between the 9100 twin sensor and the 9100 standalone in side by side in markets in approximate same water use, the exact same water systems over a 12-month period of time. And the 9100 twin sensor unit works out to be 10% more efficient on water and salt than the standard 9100 system in the same water quality. Now, if you extrapolate that across water qualities that vary greatly in that same time period, it's even more of a profound savings. So even if you have 9100 twins in your system, the twin sensor will even give you more efficiency and savings out of it. So how does it work? The sensors adjust the hardness. The meter determines the regeneration point based on resin capacity between the sensor probes. Percentage of resin below the lower probe is set at a fixed volume. 20% plus or minus adjustment of hardness max between each regen. So you can actually tweak this digitally inside the controller between regenerations if you need to. There's currently 4 configurations based on tank size selected: 8, 9, 10, and 12 inch diameter tanks in the 8 by 44, 9 by 48, 10 by 44, 10 by 54, 12 by 48, 12 by 52. Sensor tanks are available from Chardon, Ohio. The upper portion of the tank does not affect regen or hardness adjustment. We're not sensing this. We are sensing capacity between the two probes. It's a fixed distance, so it's a fixed amount of resin. Once we sense that, we're going to count how many gallons from point A to point B here, and that determines how much capacity is left. We're going to readjust the hardness level and set that for from here all the way through the tank until the next phase. So once it sets here, it's going to adjust, and if it's going to switch and regenerate, it's going to go through this tank next with that new setting, where these new probes are going to pick it up, and it's going to sense here and then through this one. So it's a continuous loop of sensing between the two tanks. So you're really going to be adjusting hardness every time you regenerate a tank. And that's going to lead to an in real time savings of salt and water. Below the sensors, the amount of capacity below the sensors can be adjusted in the electronics for higher accuracy, especially if you're putting gravel or down at the bottom for increased flow. Here, you're going to need to be able to adjust that in your sensors. So you can put gravel in these tanks. You just have to adjust that amount here. Components here, it's the 9100 Fleck valve. It has a different controller. It's a logic sensor controller on this unit. It has some specialized unique parts to this system. The tanks, the sensors, the regulated brine system on this unit, and upflow pistons. So these are upflow as well. So we're trying to extract as much efficiency out of these units as possible. That's what it looks like. And those are our twin systems. Are there any questions?